The circuit all starts with an analog input. Then through a NAND logic gate, it is converted to a digital input. From here, the signal enters the NAND gate oscillator. The oscillating clock signal then enters the decade counter. The only purpose of this is to divide the clock frequency by 10. Then, the slowed clock signal enters the decimal binary up-down counter, where the clock signal is used to count out a binary number. This is outputted over 4 pins. These outputs lead to the final IC, the binary counting decimal decoder. This is where the number is finally converted into specialized outputs that drive the 7-segment display. Here is the analog input. It is connected to a NAND gate oscillator. The oscillator is responsible for creating a clock signal that is the base for all counting within this circuit. Here is the decade counter. Its only job is to divide the incoming frequency by 10. Then output that to the next clock input. Then comes the decimal binary up-down counter. This is responsible for doing the counting. It is able to take in a slowed clock signal, then output a binary number through 4 outputs. This counting can go up or down depending on if pin 10 is set high or low. Up next is the binary counting decimal decoder. This takes in the binary number through the 4 inputs and converts that to a decimal number, and one that can be displayed on the 7-segment display. The last part of this circuit is the 7-segment display. This is responsible for displaying the decimal converted binary number. Finally, I was given a PCB with all the connections already done. This also fits perfectly into the 3D printed case that I was given.